friends. My name is Vasanth. I'm studying in class 9 from Depot School, Upnagaram. Today I'm going to explain you about earthquakes, its causes and its structure. What are earthquakes? An earthquake is a tremor which causes shaking of the earth's crust below the surface of the earth. Now, as you noticed, we have seen major earthquakes occurred in the earth. So now you might get a question, what are the causes of earthquakes? I'll explain you. Earthquakes are caused by the strain which is a result of a number of factors. When the earth's crust is unable to accommodate itself to the strain, it results in a sudden violent shock. A series of shocks that occur in sudden movement are called seismic waves or earthquake waves. The waves spread through the seismic focus and the earthquake and causes widespread destruction. So the main factors that cause earthquakes are volcanic eruptions, plate tectonics, folding and faulting, and some other man-made causes. Volcanic eruptions. Volcanic eruptions are the major cause of the earthquakes. During volcanic eruptions, hot gases are pushed upward and they cause violently the earth's crust to cause earthquakes. Now, volcanic eruptions and earthquakes are interrelated. That means an earthquake follows a volcanic eruption and volcanic eruption follows an earthquake. Now, plate tectonics. Plate tectonics is the second cause of the earthquakes. The crust of the earth is made up of a series of movable plates. These plates move and slide over each other. When they slide and collide each other, they just produce faults. Folding and faulting is a third cause of the earthquakes. Internal horizontal and vertical movements due to compressional tension causes folding and faulting. Such an imbalance causes earthquakes. For example, in 1906, San Andreas Fault of California in USA gave rise to an earthquake in which the Richter scale magnitude is 8.3 and broke the Earth's surface with 402 kilometers in depth. Now, man-made causes. There are some man-made causes which causes earthquakes. They are construction of dams, blasting of rocks, mining, etc. Now, for example, Koyna Dam in Maharashtra gave rise to a Koyna earthquake due to construction of Koyna Dam. So next, I am going to show you a PowerPoint presentation on anatomy of an earthquake. Anatomy of an earthquake. The tension caused by the movement of the tectonic plates of the earth builds up and is released in the form of powerful vibrations. These vibrations travel in three types of waves: primary waves, secondary or shear waves, long or surface waves. Primary waves. Primary waves are the first earthquake waves to be recorded on a seismogram of an earthquake. They are compressional, that is, the particles vibrate in the direction of a movement of the wave similar to a sound wave. They can pass through solids, liquids, and gases. Secondary waves. Secondary waves are recorded on a seismogram after the P waves. They are distortional waves in which the particles vibrate at right angles to the direction of movement of that wave. Secondary waves travel through the Earth's interior but cannot be transmitted by liquids. Long waves. Long waves travel along the surface of the Earth and are recorded after the P and S waves. Two types of L waves are identified: love waves, Rayleigh waves. This is the picture of the seismic waves, or called the earthquake waves. The P waves and S waves travel through the interior of the Earth. The surface waves are the last to arrive. The point of origin of seismic waves is called seismic focus. On the Earth's surface, directly above the seismic focus, is called epicenter. Most of the earthquakes have their seismic focus between 8 to 35 km in depth. This is the picture of the internal part where the earthquake occurs.
Seismograph. The direction of movement of waves and their passage is recorded by an instrument called seismograph. It has a pen attached to it. This pen vibrates with the earthquake waves, recording their movements on a traveling strip of paper. It also calculates the difference in the arrival of P and S waves. This interval is then used to calculate the distance between the recording station and the epicenter. Richter scale. The Richter scale measures the power of an earthquake on a scale of 1 to 9. It measures the intensity with mathematical precision. Richter scale is most commonly used for measuring earthquake intensity. Each point upward from 1 represents tenfold increase in the amplitude of shock waves.
Hi there, I'm Nischal. Let me explain effects of earthquakes. There are two types of effects, namely constructive and destructive effects. Now, coming under constructive effects, energy release. Earthquakes help the earth release its stored up energy. This energy release helps to keep the earth in good shape. Landforms. Earthquakes may rise or lower parts of the earth, especially near the shore. Landslides triggered by the earthquakes cause formation of lakes and etc. Destructive effects. Collapse of structures. Humans have settled in active earthquake zones. Often these houses and other structures collapse, causing great loss of property. Submergence. The forces of uplift and subsidence also cause submergence of coastal parts. Course of rivers. Earthquakes have changed the course of rivers in past, thus rendering many areas unsuitable for irrigation and agriculture. Danger to human life. Many severe earthquakes in the past have killed hundreds to lakhs of people. They died on account of house collapse or under the weight of falling trees, poles, bridges, other structures. Landslides and floods caused by earthquakes also kill many people and animals. Landslides. The shock waves during an earthquake destabilize the loose rocks which lead to landslides. This damages the buildings and disturb the transport system. Fires. During the earthquakes, fires break out, damaged oil refineries and live electric wires catch fire and damage life and property. Tsunami. A tsunami is a destructive ocean wave that can be generated by any disturbance that rapidly displaces a large mass of water. The most common cause is an undersea earthquake or a seashore earthquake. Flash floods. Strong shock waves damage dams and embankments, and the water stored there spreads speedily, causing flash floods and cause damage to life and property.
This is Naveena of class 9th E and I am going to explain about the distribution and prediction of earthquakes. Three major earthquake belts in the world. Let us discuss about them briefly. Number 1 is the Circum-Pacific Mountain Belt. This belt has 70% of all earthquakes. A part of San Andreas Fault in the USA lies in this belt. This fault zone makes California in USA highly prone to earthquakes. The areas of Japan, the Philippines and Indonesia all form parts of this belt and are prone to severe earthquakes. So we can notice that these areas are in Pacific Ring of Fire or the Circum-Pacific Mountain Belt. Second one is the Mid-World Mountain Belt. It stretches from Eastern Europe, covering alpine Himalayan ranges in Europe and Asia. About 20% of all earthquakes occur in this zone. So we can notice the alpine Himalayan ranges. Third one is the Mid-Atlantic Ridge. This belt comprises areas along the mid-oceanic ridges as well as many islands near the ridges of the Atlantic Ocean, and the remaining 10% of earthquakes occur in this belt. In this ridge, two tectonic plates move in opposite direction. Some moderate earthquakes are recorded along the ridge. The Rift Valley of East Africa is considered as an extension of this belt. Picture, we can notice the Mid-Atlantic Ridge. We have discussed earlier the distribution of earthquakes, and now let's see about the predictions of earthquakes. Earthquake predictions in the past was left to astrologers and mythics. Today it is a respectable scientific pursuit. The Russians were the first to discover P and S seismic waves in 1960s, on the basis of which predictions were made. These waves
still are only the means available to seismologists to predict earthquakes. The theory of plate tectonics offers another means of predictions on the scientific lines. Japanese use the methods of measuring changes in the sea level and variations in the Earth's magnetic field. However, no method is still foolproof, as has been proved by recent earthquakes in Japan, India, and USA.